Alright guys, welcome back. Quick shout out to Matt and Syed, because why not? Hey. We're going to do inverses today, and most of this is actually written down for you, but real quick introduction. Inverses basically flips everything that you're used to thinking about. It maps outputs back to original inputs of a function. So for example, if I give you a function that's 2, 4, 4, 8, so like your x values are 2, 4, 6, 8, and your range or your y values are 4, 8, 12, 16, the inverse of that would be for the inverse function, it would be 4, 8, 12, 16 for the domain, or the inputs then, and the range now becomes 2, 4, 6, 8. So basically flips domain and range. Graphically, it's a reflection over the line y equals x. This is key. You basically switch the x and y coordinates. So, for example, well, let's plot a point or two. Let me do point 1, 2, 3, 1. There's 3, 1. The inverse of that would be 1, 3. So let's find where 1, 3 is. 1, 1, 2, 3. There's its inverse. And sure enough, it looks like it was reflected or folded over that line. So these are inverses. Let's do one more. I don't know. Negative 2, 2. Negative 2, 2. The inverse of that would be 2, negative 2. So I go over to 2, negative 2. And sure enough, it looks like those green dots, I mean, it's not perfect because my scale isn't perfect, but it flipped over. So all you do to graph something is take the points from it and just switch the x and y. Now, doing an equation is the same thing. To find an inverse, you switch the x and y values, and then you solve for y. I forgot to write that. Let's write that down. Solve for y again. So, let's say I have an original equation of y equals 2x minus 4. I want to find the inverse of that. So the first thing I do is I switch the x and the y. So I rewrite it as x equals 2y minus 4. Okay. Now I solve this for y. So I'm going to move the 4 over and then divide by 2. So I get y is equal to x plus 4 over 2. Or you can write this as, if you split it into two fractions, like we do for slope-intercept form, 1/2 x plus 2. So that's the inverse. That would map so if you put the range values back in as your domain, you'll get the old domain values back out. Okay? Another thing we do is called verifying inverses. Okay? To verify if two things are inverses of one another, you have to just do composite functions. If you do f of g of x and your output is x, and then you do g of f of x and your output is x, then they are inverses. You have to do both of them. Sometimes one works and the other one doesn't. We saw that actually, I think, on one of the prior lessons. Sometimes we got x out. So first off, let's do f of g of x. F of g of x means I'm taking g of x and sticking it into f of x. So I have 1/2 parentheses 2x minus 2 plus 1. Distribute the 1/2, I get x minus 1 plus 1, which is x. So the first part is correct. Now let's verify g of f of x. We can do... So we're sticking f of x into g of x. So I have 2 times the quantity 1/2 x plus 1 minus 2. Distribute the 2. X plus 2 minus 2 is x. So f of x and g of x are inverses. So let's write that real quick. Here's another thing I want to talk about. On the quiz or test, if you're doing these problems and you get x out but your algebra is incorrect, like you just do something wrong algebraically, you're going to get a point off. Okay, you have to show me the steps and they have to be correct. They can't just magically be x all of a sudden. Now, it shouldn't be that difficult, but some of you guys do things in the wrong order, which makes it more difficult. Okay, so Now let's talk about an inverse of a nonlinear function. Well, let's solve for it first. So f of x is equal to x squared. Now, if I give you f of x, you don't say y for the inverse. You say f inverse of x. So, for example, if I'm solving this and I change it and I say x is equal to y squared, I want to find the inverse. I take the square root. Now, notice how both pieces are involved here. So that means that when I take the square root, I get y is equal to, you need plus or minus square root of x, or else you're only going to get one part of the curve. And so that means I'm going to rewrite it as my inverse, f inverse of x equals plus or minus root x, or y in, yeah, so that's your inverse, you know that. And if you graph that on your calculator, it should look something like this. A parabola that opens up sideways. Okay? So let's talk about the original function first. So the original function, I'll do the original function in red, had a domain of anything. X could be anything, you could plug anything you want in there. Our y, our range, were y values such that y was greater than or equal to 0. Just by looking at the graph, it stops at that vertex at 0 and goes back up. It never goes down. So, without even looking at my inverse that I just drew, the domain for the new graph should be that x is only greater than or equal to 0, and my range should be that the y is all real numbers. And the reason is that the inverse just flips the domain in the range. And sure enough, if you look at the graph, that's true. X is only positive. Y can go up or down forever. Okay, so let's do it one more time. Let's talk about this problem here. Let's find the domain of the original. So my domain looks like I could have x's of any value. And my range goes top to bottom. Goes all the way up forever, all the way down. So it also looks like that I can have all real numbers. Make sure you use the correct letter when you're doing range versus domain. Sometimes people do range with x's, and that's not correct. Alright, so let's solve for inverse of g. So I'm going to flip the x and the y, so it becomes x is equal to y cubed. I take the cube root, and that is my new function. Okay? To graph that, if you graph that on your calculator, you can see that it looks something like this. Okay, and we're going to talk about those tomorrow, but again, x goes off forever and y will go off forever. So my domain is everything. And we should rewrite this as g inverse of x also, because it was given to us as g of x. So this is the correct answer right here. So, x is all real numbers for domain and range. The y is all real numbers. In domain and range, you can use y. You don't have to use g of x. It's just better. But if I give you the problem in g of x, you should probably use g inverse of x. Now, the last thing, horizontal line test. Here's where people get confused. You use the horizontal line test to see if the inverse is a function. So we don't see the inverse. There's two things you can do. You could either graph the inverse and see if it's a function using the vertical line test like before, because the vertical line test tells you if the thing on the page is a function. Okay? So, let's look at this problem right here. Right away, this thing is a function, because if you draw vertical lines, it only hits it once. But if I want to know if the inverse of this, so not this graph itself, but the inverse of this problem is a function, and I didn't know how to switch it because of absolute value, all you have to do is a horizontal line test. If it hits more than once, it's not a function. So is this inverse a function? No. Alright? The domain of the inverse would be the range of the original function. So let's get that information first. The range of the original function is that y, well, this point is at -3, right? Y is greater than or equal to -3. Hopefully you guys see that. It starts at -3 for y and goes up forever. Which means the domain of the inverse, if I graph the inverse of this, the domain would be that x is greater than or equal to -3. How long is this? Okay, so let's just real quick. I want to show you now. So that's the horizontal line test. If it hits twice horizontally, the inverse isn't a function. Let's explore that now. Let's look at the inverse real quick. Let's graph it. All you have to do is flip points. So for this graph, I have the point -2, -3, which means that the new point is at -3, -2. All right, so that's 1 point. I have this point 1, 0, so I have 0, 1. I have this point over here, which is 1, 2, 3, 4, 5, -5, 0, so I do 0, -5. 3, 4, 5. Okay, so it looks like this absolute value is going to be doing this. And there it is. That would be the inverse of that. And sure enough, if you look at the domain now, x starts at -3 and goes off forever, and it fails the vertical line test, which means it's not a function. So the horizontal line test before already told us that, but you can also graph it and do the vertical. Alright, so that is how you can tell if an inverse is a function or not. Either graph it and do the vertical line test, or just use the graph of the original and do the horizontal. And that is all.